Hey there, boys and girls. This is Miss Estes, and today we're going to be talking about multiplying fractions. Our I can statement is I can apply and extend previous understanding of multiplication to multiply a fraction or a whole number by a fraction. So let's begin with some models. If we take a look at this model, we're going to use this model to multiply 1/2 times 1/3. So you can think of the product 1/2 times 1/3 as finding 1/2 of 1/3. So I'm going to write the word of right here above this multiplication symbol because we're finding 1/2 of 1/3. Each row is half the whole, so we have 1/2 here and 1/2 here, and each column is 1/3 the whole, so we have 1/3, 1/3, and 1/3. The whole is divided into 6 equal parts. So once we shade each fraction, the part that is shaded yellow and blue will represent the product. So let's start shading so then we can see a little better what we're talking about. So we're going to begin by shading 1/2 yellow. So like we said, each row is equal to 1/2. So we want to shade one of these rows to represent 1/2 of the whole. All right, so there we have 1/2 shaded yellow. And now we're going to shade 1/3 blue. I'm going to shade one of these columns to represent 1/3. All right, so now we are going to focus on the part that is shaded yellow and blue. So if I look at my model, I see that there is one piece that has both yellow and blue overlapped. So I can see my numerator is going to be 1, and there are 6 parts in the whole. So that shows me that our product is going to be 1/6. If we take a look at this next model, we're now multiplying 2/3 times 3/4. So to solve this problem, we are going to find 2/3 of 3/4. So again, I'm going to put the word of here because we're finding 2/3 of 3/4, or 2/3 times 3/4. So 2 rows show 2/3 of the whole, and 3 of these columns will show 3/4 of the whole. As we can see, this whole is divided into 12 equal parts. And again, the part that is shaded yellow and blue will help us see the product. So we're going to do yellow first, and we're going to shade 2/3 yellow. So we need to make sure that we shade 2 out of these 3 rows to represent 2/3. There's 1/3. And then our second row gives us 2/3. All right, so now we're going to shade the blue, and we need to shade 3/4 blue. So one column would be 1/4. Then there's 2/4 and 3/4. And again, we want to now focus on the part that is shaded both yellow and blue because that is going to show us the product. I'm going to circle the pieces that are yellow and blue. So if we count, we see there are 6 yellow and blue pieces, and there are 12 in the whole, 12 equal parts. So that represents 12/6. I mean 6/12. I also know that 6 is half of 12, so that shows me that this is equivalent to 1/2. So 6/12 or 1/2 would be our product. All right, well now let's take a look at multiplying fractions without models because we won't always have those models to help us to multiply. So we have 3 easy steps to multiply fractions without the models. In our first step, we're going to multiply the numerator. So all we're going to do is just multiply across. Then number 2, we're going to multiply the denominators across. And then number 3, then find simplest form or convert to a mixed number. And that's if it's not already in that simplest form. So let's take a look. We have 1/2 times 1/3. This is that very first model problem that we solved. So if we follow our steps, multiply the numerator, 1 times 1 is 1, and 2 times 3 equals 6. So that gives us the product of 1/6. And if we think back to that first model that we shaded, that's exactly what we came up with. There was only one piece that was shaded yellow and blue, and there were 6 pieces in the whole. We know that this is in the simplest form because it has a denominator of 1. It's a unit fraction. It can't be reduced any smaller. All right, so here's our second example that we used the model to solve. 2/3 times 3/4. So step 1, we're going to multiply the numerator. So 2 times 3 is 6. Then we're going to multiply the denominators. 3 times 4 is 12. And just like before, we know that 6 is half of 12. We can divide both of these numbers by 6. And 6 divided by 6 is 1. And 12 divided by 6 is 2. So it reduces to 1/2. And that's exactly what we came up with when we use the model. So it doesn't matter if you use the model or you don't use the model, you still should come up with the same product. Okay, now we're going to take a look at area and fractions. I can find the area of a rectangle with fractional side lengths. Sometimes we don't have those nice, neat numbers of whole numbers when we're trying to find the area. Sometimes we do have fractions that we have to multiply with. So the first thing we need to review is our formula for area. We know that area equals length times width. We need those two dimensions in order to find the area of a rectangle. So starting with our rectangle over here on the left-hand side, we see that it has a length of 4/5 of an inch. So I'm going to write 4/5, and it has a width of 4. So just like with our problems that we just solved, we're going to multiply our numerators and multiply our denominators. But I see I don't have a denominator because we're multiplying by a whole number. So I'm going to put this over 1. So that way I'm not changing the value of the number, but now I am less likely to make a careless mistake because I now have 2 numerators and 2 denominators. So 4 times 4 equals 16, and 5 times 1 equals 5. And we have an improper fraction, so we want to try to rewrite this as a mixed number. So I know that 5 will divide into 16 3 times. We can make 3 groups of 5 with 1 left over. So that gives us an area of 3 1/5 square inches. We always have to make sure that we express our area in square units. Our second rectangle. So we have a length of 2 inches and a width of 3/4 of an inch. And again, we're multiplying a whole number by a fraction. So I'm just going to put a 1 under that whole number. So again, I have 2 numerators and 2 denominators. And I'm going to multiply across. 2 times 3 equals 6. And 1 times 4 equals 4. Again, we have a mixed number, an improper fraction that we want to write or change into a mixed number. So we can make one group of 4. And we are left with 2/4. All right, we're left with 2/4. But I need to look a little further at 2/4. I know that 2 is half of 4, so I can divide both of these by the number 2. And once I do that, I'm going to end up with 1 1/2. So I have an area of 1 1/2 square inches. All right, so let's take a look. We have a couple more examples that we're going to work through. So we have a rectangle with a length of 3 inches and a width of 3/4 of an inch. So we want to multiply length times width. And again, since we're dealing with a whole number, I'm going to put that over 1 so we can multiply across. 3 times 3 is 9. 1 times 4 is 4. 4 will divide into 9. We can make 2 groups of 4 with 1 left over. So that gives us an area of 2 1/4 square inches. Next, we have 2 fractions as our dimension. So we're going to multiply 3/4 times 4/5. 3 times 4 is equal to 12. 4 times 5 is equal to 20. So we have a proper fraction, but we need to look at it a little further to see if this fraction can be reduced or simplified. So we want to try to find the greatest factor that they have in common. Well, I know that both of these numbers have 4 as a factor. So we can divide each by 4, and 12 divided by 4 is 3, and 20 divided by 4 is 5. So that gives us an area of 3/5 of a square inch. Our last example, I noticed here that we have a mixed number for one of our dimensions. So we're having to multiply 1.5 times 4/5. Well, if we have a mixed number, we have an extra little step that we need to do because we cannot multiply the whole number and the fraction. So what we're going to do is we're going to take this whole number, this mixed number, and we are going to rewrite it as an improper fraction. So 2 times 1 is 2, plus 1 is 3, so that gives us 3/2 as our improper fraction. And we are going to multiply this by 4/5. So now we have 2 numerators, 2 denominators, and we can just multiply across. 3 times 4 is 12. 2 times 5 is 10. And now we need to turn our improper fraction back into a mixed number. So 10 will divide into 12 one time, and we have 2 left over, so 1 2/10. But let's look at 2/10 a little bit further. I know that they are both divisible by 2, so I'm going to divide my numerator and denominator by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. So that gives us an area of 1 1/5 square inches. So wrapping up multiplying fractions, we first want to make sure we multiply the numerator. Second step, we're going to make sure that we multiply the denominators. And then our third step, we are going to find the simplest form or convert to a mixed number. And like we said when we were practicing it, you might always not have to do step 3, but it is something that you need to make sure you check your fraction for. If you have an improper fraction, you definitely want to convert that to a mixed number. But if you have a proper fraction, you have to look at it very carefully just to make sure that it's already in its simplest form or reduced form. So that's all you need to do, guys. 1, 2, 3. Thank you.